Welcome back, Physical Science 20. This is the 7.4 section, calculations involving limiting reactants. So in the previous video we looked at what do we mean by limiting in excess reagents or reactants, and hopefully you have a good understanding of that now, that we're limited in one thing and we have possibly extra of other things. So for example, when you have an equation like this, titanium tetrachloride, if we were combining with magnesium to isolate titanium. Of course, titanium chloride, tetrachloride, is very expensive, so we'd likely be limited by how much of that we have. And if we wanted to extract all the titanium we could from there, you can see it's a 1 to 2 mole ratio here for titanium tetrachloride and magnesium. So we'd want to have at least 2 moles for every 1 mole, and likely even more. We want to make sure magnesium is slightly excess to ensure that we can pull out all of the titanium we possibly can from there. Okay, so this section deals basically with two parts here. The first part, we take a look at it a little bit easy. We go from a mole to mole standpoint, and then in the second half we go from a gram to gram standpoint, which has a couple of extra steps. So first of all, when you have your reactants in moles, the first step, you have to figure out, okay, what is my limiting reagent? What is my excess reactant? Once we figure out our limiting reagent, we use that amount to predict how much product will be made. It's the limiting reagent that determines how much product is made. So if we look at this example, one dealing with that titanium tetrachloride and magnesium example, it says determine the amount, and of course by amount this booklet means moles, of titanium metal produced when we have 2.8 moles of titanium tetrachloride and we have 5.4 moles of magnesium. Okay? Whenever I have something like this, I like to write mole amounts over top of the equation. So I have 2.8 moles of titanium tetrachloride, 5.4 moles of magnesium. So you can see the example here, they write underneath. I like over top, but whatever, it doesn't really matter. So we start with one of these. The example here just chose to start off with 2.8 moles of titanium chloride to see how much magnesium would be required. Or you could have done it vice versa. You could have started with this and figured out how much of this you need. It doesn't really matter. So 2.8 moles of titanium tetrachloride, and according to the mole ratio here, 1 mole requires 2 moles. 1 mole requires 2 moles. So if I have 2.8 moles of titanium tetrachloride, I need 5.6 moles of magnesium. Do I have 5.6? No, I don't have enough. I only have 5.4 moles of magnesium. So that tells you that I have less than required to react all of titanium tetrachloride, so that means magnesium must be my limiting reagent. I'm limited by that because I don't have enough to react with all of this 2.8. So magnesium must be the limiting reagent and titanium tetrachloride must be excess. Okay, and going on, if I did the reverse there, you would reach the same conclusion if you had gone vice versa. So if we had started off with 5.4 moles of magnesium, it's a 2 to 1 ratio. So 2 to 1 ratio, I would require 2.7 moles of titanium tetrachloride. And yes, I have 2.8, so I have 0.1 extra. So you can see it doesn't matter which one you start with, you'll get the answer regardless. And of course, we use the limiting reactant in the calculation to figure out how much of the required substance we need or how much product will be produced. And this question, let's see, it did ask for how much titanium metal is produced, so we use our limiting reactant 5.4, and it's a 2 to 1 ratio when going from magnesium to titanium. So 2 to 1, 2 to 1, so you can see 2.7 moles of titanium is produced. Okay, so next here I have the practice questions 1, 2, 3, 4. I'm going to do the first one with you, so we can see exactly how to do that. And then I'd like you to run through questions 2, 3, and 4, whatever you think you need to do. And of course the answers are here, which are nice because you can check your work. Okay, over here it says nitric acid spill is neutralized by adding sodium hydrogen carbonate or baking soda. What amount of water is produced when 2.3 moles of nitric acid is combined with 2 moles of sodium hydrogen carbonate? So of course the 2.3 and the 2.0 are not stoichiometric amounts. They're not going to be completely used up. And the nice thing about this question is that it's a 1-to-1 ratio here. So you can get the limiting reactant right off the bat without even actually having to calculate it. But we are going to run through the calculation anyway here. So if I start off with nitric acid, 2.3 moles of HNO3, and of course it's 1-to-1. 1 mole of HNO3 reacts with 1 mole of NaHCO3, so we would need 2.3 moles of sodium hydrogen carbonate, but I only have 2 moles. So that tells you right there that I'm limited by sodium bicarbonate, so that is going to be my limiting reagent. So sodium bicarbonate is a limiting reagent since only 2 moles is available. Okay, so to figure out how much water is produced, then I use my limiting reagent, and it's also, look at that, a 1-to-1 ratio. So 1 mole of sodium bicarbonate makes 1 mole of water, so 2.0 moles of H2O is produced. Okay, so relatively easy when it's a 1-to-1 ratio. Number 2 here, chlorine can be produced in the lab by reacting hydrochloric acid with manganese 4 oxide. So if we take a look here, it says here what amount of chlorine can be made if I have 5.2 moles of hydrochloric acid and 1.5 moles of manganese dioxide. So I just set that up over top of each. I could start with this one and figure out how much of this I need, or start with this, figure out how much of this I need. It doesn't matter. What did I choose? I chose hydrochloric acid. Doesn't matter. 5.2 moles of HCl, and we can see here it's a 4-to-1 ratio. So 4 moles of HCl will be required to react with 1 mole of MnO2. So that works out to be 1.3 moles of MnO2 required. After, of course, I can cancel this off. And if we look here, how much MnO2 do we have? Oh, we have 1.5. We have extra even. So we have enough plus extra. So that tells you that this is my excess reagent, and this must be my limited reagent. So 1.5 moles of MnO2 is available, therefore it is excess. And of course, therefore the other one is limiting. So HCl is my limiting reagent. So that's what I'm going to use to figure out how much chlorine is produced. Because remember, you always use the limiting reagent. So doing that, 5.2 moles of HCl, and the ratio here is 4-to-1. 4 moles of HCl produces 1 mole of Cl2. 4 moles of HCl produces 1 mole of Cl2. So that works out to be 1.3 moles of Cl2 produced. And I just made a further note there. Yes, be sure that the limiting reagent is used for the final calculation. Okay? So that's the end of part 1 of the video. If I were you, I'd go through parts for question 3 and question 4 here. You have to make up the equation for each of these, so you have kind of an extra step in there, and then see what you can do from there. And hopefully you get the right answers that are illustrated there. And of course, if you're running into any problems, please see me and we can see where maybe a mistake may have happened. Okay, we'll see you again.